Good day everyone, this is Gifted Brain aka Saizu. Today we shall be considering Indices 1, which is Introduction to Indices. Under this study, we shall be considering 1. Introduction to Indices, 2. Laws of Indices with several examples. Indices. The index of a number shows how many times a number is multiplied by itself. Actually, the index is a power or exponent which is raised to a number. For instance, now let's look at this. If I say 5 raised to power 4, this simply means that I should multiply 5 by itself in 4 times. So 5 times 5 times 5 times 5. So the 5 raised to power 4, the 4 there is the index. It's telling me how many times I should multiply 5 by itself. So simply put, the index, like I said earlier, is the number of times you have to multiply a number by itself. That's what the index give you. Actually, the 5 here is called the base. The base. Okay? So if I say 3 raised to power 6, 6 here simply is the index. And again, index is simply telling me that I should multiply this 3 in 6 places. 3 times 3 times 3 times 3, the fourth one, times 3, the fifth one, and then times another 3, which is the sixth one. So that's what the index means. Please take note that the word index is a singular form of indices. So if I say index, I'm talking about singular, and if I say indices, I mean plural. Indices is governed by several laws, so we shall be considering the laws of indices. Law number 1. The law number 1, which says x raised to power a multiplied by x raised to power b is equal to x raised to power a plus b. And this law is simply saying that if I have, maybe for instance, a number 5 raised to power 2 multiplied by 5 raised to power 7, for instance, and you can see something here. These two indices has same base, and because of that, applying the multiplicative law means to add the power. That's just what the multiplicative law is saying. Add up the power. So this will simply be 2 raised to power 5 raised to power 2 plus 7. That is 2 plus 7. That is just simply what I am doing. Like 5 raised to power 9. So let's look at the following example now. Example number 1 says, simplify the following using the multiplicative law of indices. And so for the first one, which is 3 raised to power 5 times 3 raised to power 2, this will give me 3 raised to power 5 plus 2. And that's 3 raised to power 7. So that's all. You can go further to get what 3 raised to power 7 is, but you don't always need that. And so 2 raised to power 8 times 2 raised to power 4 simply give me 2 raised to power 8. Just add up the power. 2 raised to 8 plus 4. That's simple. And that is 12. 2 raised to power 12. Again, 5 raised to power 3 times 5 raised to power minus 1. And that will simply be 5 raised to power, add up the power, 5 raised to power 3, 5 raised to power 3 plus add to minus 1. And in this case, it will be 5 raised to power 3 plus minus 1. And that will be plus times minus. And you know, when you say plus times minus, you will have minus. That's 3 minus 1. And that will give us 5 raised to power 2. Because the plus and minus are written side by side, so they will multiply each other. And so take note again, I have 4 raised to power 3 times 16. And the first law cannot be applied in this number, the fourth question. The reason is because the first one has a base of 4, while the second one is not an index. It's not written in index form. So I have to look for how do I solve this problem. Well, 16 can also be written as 4 raised to power 2. And so when you recognize that, then you can start applying the law of indices. You can write as 4 raised to power 3. So rather than writing 16, you can now write 4 raised to power 2. And that will give you 4 raised to power 3 plus 2. And that's 5. And so take note of that. We also have 2 raised to power 3 times 5 raised to power 2. If we do that accurately, we have 2 raised to power, okay, sorry. Law of indices cannot be applied here. Law of indices cannot be applied here. Sorry. Law of indices cannot be applied. And why? It's because the two numbers, the two indices are not having the same base. Yes. So they're not having the same base. So because of that, law of indices cannot be applied. Doesn't mean you cannot solve this question. You can still solve, but not applying indices. Briefly, I can say that, 2 raised to power 3 times 5 raised to power 2 can be 2 raised to power 3 is actually 8, which is 2 times 2 times 2, which is 8, times 5 raised to power 2, which is 25. 5 times 5 is 25. So you can say the answer is 200. Yeah, I solved this actually, but I didn't apply the law of indices. So take note of that. So if law of indices must be applied, the base must be the same. So that's that about that. Let's look at the second law now. The second law, which is also called the divisibility law. What is it simply saying? It's saying that, for instance, I have s raised to power a divided by s raised to power b. The answer is simply s raised to power a minus b. When two indices are dividing, then you have to, or when two indices are dividing, you have to subtract the power. That is just what it's simply saying. So let's look at this example 2 now. The first one says 10 raised to power 5 divided by 10 raised to power 2 is simply going to be 10 raised to power 5 minus 2. And that's 10 raised to power 3. The second one simply says 6 raised to power 2 divided by 6 raised to power minus 3. It's simply going to be 6 raised to power 2 minus, then the number minus 3 again. Because minus and minus are next to each other, we have to multiply them. The minus times minus will give me plus. That will be 6 raised to power 2 plus 3. And my answer is 6 raised to power 5. Very simple. The third one, 4 raised to power 2 divided by all over 4 raised to power 4, which is same thing as divide. All over means divide. So this will be written as 4 raised to power 2 minus 4. And that will give us 4 raised to power minus 2, because 2 minus 4 is minus 2. This should be simplified further, but we've not gotten to this law, so I'll leave it as 4 raised to power minus 2. Look at the fourth one. Law of indices cannot be applied. Why? Because they don't have the same base. So take note of that. Let's look at the third law now. Actually, the third law is very, very simple. It simply states that anything raised to power 0 is 1. Anything raised to power 0 is 1. And so s raised to power 0 is 1. Y raised to power 0 is 1. Your nose raised to power 0 is 1. 1 million raised to power 0 is 1. House raised to power 0. Anything that is raised to, anything, both you can say or you cannot say, anything raised to power 0 give you 1. Even you watching this video, if I raise you to power 0, you will still be 1. So let's look at lastly the fourth law. So the fourth law of indices, which says s raised to power minus a can be written as 1 over s raised to power a. It means that if something is raised to power a negative number, the negative number can be removed, the negative can be removed, the minus sign can be removed by writing as 1 over, but removing the negative number of whatever the index is. So take note of that. For instance, now let's evaluate the following. 5 raised to power minus 3. This can be written as 1 over 5 raised to power 3. And mind you, m raised to power minus a can be written as 1 over m raised to power a. And 5 raised to power minus 1 can be written as 1 over 5. Actually 5. You know why? Because anything raised to power 1, actually you'd have said 5 raised to power 1, but anything raised to power 1 is itself. So whenever you have anything raised to power 1, you write that thing without the 1, because there's no need to do that. You see, this fourth law is reversible. I can as well say that 5 raised to power 2 is equal to 1 over 5 raised to power 2 if need be. And then 5 raised to power minus 2. If you see, m raised to power a can also be written as 1 over m raised to power minus a. So like I said, it's reversible. So 5 itself can be written as 1 over 5 raised to power minus 1. So take note of that. So fifth law of indices says xy raised to power a is equal to x raised to power a multiplied by y raised to power a. What this law is simply saying is that, for instance, let's say we have t z raised to power b now. Obviously, we know that tz means t multiplied by z now, all raised to power b, and that will simply be t raised to power b multiplied by z raised to power b. That's what the fifth law is saying. So let's simplify the following now. Let's say we have 10 raised to power 3. To be able to apply fifth law now, I will simply say what is the multiple of 10 that I know. Now, as an example is 2 multiplied by 5. Now, using these multiples now, I can apply the fifth law. You know, there is a power of 3 there. So it will now be expressed as 2 raised to power 3 multiplied by 5 raised to power 3. The same with the second one. We have 6 raised to power 3. That will obviously be 2 times 3. I first of all look for multiple of 6, which is 2 times 3. Then with the power of 3 on it. And then this will now be 2 raised to power 3 multiplied by 3 raised to power 3 now. That's that about that. Multiple certain number. Please, it's important. This is important for some of the things we'll be doing in indices. You see, anytime you see 2 raised to power 1, it simply tells you that 2 means 2 raised to power 1, sorry. If you see 4, it means 2 raised to power 2. If you see 8, it's 2 raised to power 3. We must get used to this. 16 is 2 raised to power 4. 32 is 2 raised to power 5. 64 is 2 raised to power 6. 128 is 2 raised to power 7. 256 is 2 raised to power 8. 512 is 2 raised to power 9. Now look at the multiples of 3, for instance. If you see 3, it's 3 raised to power 1. If you see 9, it's 3 raised to power 2. 27 is 3 raised to power 3. 27 is 3 raised to power 3. 81 is 3 raised to power 4. 243 is 3 raised to power 5. So it means that if I see 243, something should come in my mind. 2 raised to power 4, 3 raised to power 5. Anytime I see 243, and that can be useful in some questions, or also may be unnecessary in some other questions too. So look at the multiples of 4. So let's get used to this. There are multiples of 5, 6, and 7. You can see them below. So this is multiples of 6, 5, and then 7. So let's get used to this. There's also 8. There's also 9. So whenever you see these things, so if I see 343, for instance, my mind goes to the fact that this is actually 7 raised to power 3, because it might be necessary for the question I want to solve. So let's look at sixth law now, the sixth law of indices. Okay, so the sixth law says s raised to power a in brackets raised to power b is equal to s raised to power a multiplied by b. What this means is, or let's simply evaluate the following, for instance. Say, look at the first one, which is 2 raised to power 2. 2 raised to power 2 multiplied by 2 raised to power 3. That will be 2 raised to power 2 times 3. And that's what the sixth law is saying now. You can see this 2 raised to power 6. And this is 64. This is 64. So that's what the sixth law is saying. So let's look at this now. 243 raised to power 1 over 5. The moment I saw 243, I know that this is a multiple of a certain number. And actually, 243 is 3 raised to power 5. So you see why I said those multiples must stick to the head. So I can write as 3 raised to power 5. So rather than writing 243, I write 3 raised to power 5. Now, raised to power again, 1 over, or multiplied by 1 over power of 1 over 5. So this can be written as 3 raised to power 5 times 1 over 5. And obviously, this will be 3 raised to power 5 over 5, which is 3 raised to power 1, and which turns out to be 3. So that's that about the sixth law. Let's look at the seventh law, and that happens to be the last law we'll be considering. So the seventh law says that s raised to power a over b can be written as b root of x all raised to power a. That's what the seventh law is. Okay, let's look at the first question. It says evaluate the following: 64 raised to power 2 over 3. So that's the first one. 64 raised to power 2 over 3. You see, this simply means this is third root or cube root, you can say. Cube root of 64. Then all raised to power 2. And what is the third root of 64? It means a number, when you multiply by itself 3 times, will give you 64. I always begin with 1 to know my answer, even though you don't. I know what the answer should be actually, but let me assume I don't know. I will start with 1 times 1 times 1 in 3 places. Obviously, this cannot give me 64. So the answer is not 1. I start with 2 times 2 in 3 places. Obviously, this cannot give me 64 because 2 times 2 is 4, 4 times 2 is 8. I go to the next number after 2, 3 times 3 times 3. So 3 times 3 times 3 will give me 27. The answer is not 3. So I move to the next number after 3, 4 times 4 times 4. And this will give me 64. So it means that 4 is that number. When you multiply by itself 3 times, will give you 64. So the third root of 64 is actually 4. 4. And then raised to power 2. So this, it means that 3 root 64 is simply equal to 4. That's what it means. So I replace 3 root 64 by 4 and raised to power 2, and that will give me 16. So that's that about that. Look at the second one. For instance, we have 32 raised to power 1 over 5. 1 over 5. And you know, that can simply be written as fifth root of 32, then raised to power 1. Obviously, anything raised to power 1 is itself. So, but what is the fifth root of 32? I'm going to start again using 1 in 5 places. 1 times 1 times 1 times 1 in 5 places. Actually, that cannot give us a 32. So that cannot give us that will give us 1. So I move to the next number. 2 in 5 places. 2 times 2 times 2 times 2 times 2 in 5 places. That actually gives me 32. And that tells me that fifth root of 32 will give us 2. So simple, I would say this is 2, then raised to power 1. That is 2. That's my answer. So the third one now, we have 729. 729. But this is raised to power minus 1 over 3. So how do we get to do this? Well, quite an easy one. It's not difficult. I can simply say from this question that we would have third root of 729 then raised to power now minus 1. And so please mind you now, third root of 729. Well, you can take this method again. Use 1, use 2, use 3. Till you get to 9, you will get realize 9 times 9 times 9. Okay, so it means that third root of 729 is actually 9. So we have 9 now. Now raised to power what? Minus 1. And that will give us 1 over 9. So that's that about the law of indices. So let's look at some examples now and see how we can use these examples, indices, to evaluate those examples.